So in the previous video we have done with how to create a node, how to insert the node at the beginning and how to display. Now we'll see insert node at the end and insert node at a given position in the single linked list. With respect to the program, how to make it, we'll see. Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. So as of now we have written, this is a program where I created a structure node and anyway it is head with null. The first node is initialized. After that we have written the logic for giving the choices to the user what he wants to do, creating a node, insert node at the beginning, insert at beginning, and display what are the elements at the current situation. Like you might insert at the node after a number of insertions. So like this we have written three functions. Now insert node at the end, how to write it? So that means I'll write a clear example here. Let us suppose this is the linked list that we have as of now. Let us suppose that means head node, this is head node where head node value is 1000, means the first node is this one, right, with the address. So the node is 10, then followed by 20, then followed by 30. Like this we have the nodes like this, the connection. Why? Because this 3000 address here you can have and this 2000 address here you have, that's why this is connected. Now I want to insert a node which is something like this, which is 40. I want to connect like this. So where I want to insert at the end like this, 10, 20, 30, 40. How to make it? I think we can do this one in two ways. One is with n complexity, other one with 1 complexity. I'll tell you both how to make it, the best one also. Okay. So first with n complexity, how to make it. So with n complexity, anyway, first I'll try to write the option which is option 5. Already option 4 is there. So option 5, where insert at end. You want to insert at end, the node at end. You want to insert the node at end, and of course I'll write the logic here. For that I want to write case here, case 5. So I'll write for case 5. Anyway you want to insert the node at the end, you have to give the value. I'll take the function this copy, and anyway I'm writing here where I want to enter a value. I'll enter a value. After that I'll write, instead of begin, the function name is insert underscore end, which I want to implement right now. We'll see that how to implement. Anyway, the basic I'll try to write it here, void, that is insert underscore end, which is a function where I want to give the value x. Yeah, and you can see now here what you want to do. First of all, I want to create a node. First of all, in order to create the node, same thing like what you have done, insert at the beginning. Okay, I'm copying that so that whatever is created, insert at the beginning, means first thing you can see here, struct node nn, a new node is created. This is a new node nn. This is a new node nn, which is with the 40, which is with the memory. Some memory will be there. Assume that this is something like 4500. And I created with memory nn of data equals to x. X means, let us suppose 40 is the value. And then what we have written here, at the next it is null. So it is null. Now it is null. Now how to connect this to here? Okay, again here also two conditions. Like what if the linked list is empty? That means you said like insert at the end, but already the list is empty. What you need to do? Whatever the current element, you need to execute the create function so that that element will be the first node. So that means I'll write the same logic like, so here I'll write the same like, if head, which is head node, is equals to null, which is a condition for linked list is empty. If head equals null, now I need to execute the create function, where create function means in fresh it will start with the value of x and it will create the node, and which will be connected that node as a first node in the linked list. If not, else what you need to do? Okay, here itself the logic changes according to the complexity n and complexity 1. So now how I need to make it? First of all, I need to traverse, I need to come to here, right? So first of all, I'll take a temp variable, t variable, I'll traverse till the last. Okay, I have to come to here. Your temp has to come here, here, like this till the last, where temp of next should be null. Once you get the last, once you get the address of the last node, what you need to do here, instead of null, what you need to write? Your new node value here. what is that address, something like what is NN has to be written. For that, what is the one thing you need to write, which is once you get here, what is temp of next, which is null, which has to become your NN. But you need to come to here first. That means you need to write a while loop so that you have to come to the last point. So that is what you have to learn clearly. So for that, I will write else part while temp of next, not temp. Temp is null, means it is going to the last node after the next one. So temp of next, you need to stop at the last node. So that's why temp of next is not equals to the null. That means you have to simply traverse. What is the traversing? You can see here, simply I am writing, updating the temp value, which is temp equals to temp of next. Simply updating. That means your temp starts from here, value 10. Next it goes to temp of next, the address. So value with 20. Next it goes to 30. So now what is temp of next? Null. So now it stops here. Now temp is where with the address 2000. Now once you come out of the while loop, I am writing outside the while loop, you can see. Now outside the while loop I am writing what? Now temp of next is null. Now that I'll make it as, which is temp of next is null. Now you need to make it as NN, which is a new node which is connected. So now when I write the line number 81, so here this address 4500, yes, it will be connected. So is there any other changes? No. Why? Because now the last node will be this node, which is 40, where the last node, the next address is null, already is there. We made it here in the line number 74, which is NN of next is null. So that's it. I think we have done with this. Very straightforward and simple. You can make it like this. So this is where I told you that this is n complexity. Why? Because you can see while loop you are writing here. That means if there are 1000 elements you want to insert at the last, you have to traverse this while loop 1000 times, then only you come here. So this is what the complexity n we call it as. Anyway, I'll execute it first. After that I'll explain about one complexity. Now you can see I'll try to execute. Yeah, what is that error? We'll check it out. Yeah, there is no temp is declared, right? So we need to declare the temp. And anyway, previously we declared inside insert underscore begin, but that is inside, there is no scope outside, that's why. So temp and you need to initialize with head. So that's what, we'll make mistakes and we'll correct it so that you will come to know. You should not forget those mistakes. Now I am executing, you can see initially the display part, list is empty, absolutely fine. Now I'll give 1 to create a node which is 10. Yeah, I'll go for one more element, insert node at the beginning first. So 20, something like this, the display is 2010, we know that. And one more element I want to insert at the beginning. First of all I'll try with beginning, 30. Yes, the display part is 30 2010, fine. Now I want to insert at the end. At the end means after 10 you have to insert that option 5. So what is the value you want to give? Let us suppose 40. Now the answer could be 30 20 10 40, right? So you can see the display part. Yes, 30 20 10 40. Like this we can make it. So 30 20 10 40. And if you want to insert one more node at the end, yes, you can make it 60. Yes, you can see the display part. 30 20 10 40 60. Like this you can insert a node at the end. Like this we can make it easily. Whatever the node you inserted, you can make at the end. Now you want to insert it at the beginning, why not option 2? So make it 5. Yes, see the display. Yes, 5 is at the first node. So like this, whatever the operation you want to do, you can do it here. Now the thing is, I told you like this is n complexity. So can I get it with one complexity? That means I don't want to write while loop inside. With constant complexity, can I get it? Yes. For that, what I need is I need one more node, which is a pointer, where similar to head node, I want to maintain a node called as tail node, where head node always points to the first node of the linked list, where tail node always points to the last node of the linked list. right? So that is what I'll take here, and I'll make it here. You can see here, this is also very most important, you have to make it, and I'm creating here as one global one tail node, which is also null initially. So null means tail node which is initially null, and what are the changes, we'll get it here. Let us suppose what is the first one? When you create a node, what you are doing, when you have simple node, one node, head equals to nn, means that node itself is the head node and tail node also the same thing, right? If you have only one node, let us suppose if I have first node, only one node in the linked list, so something value 10, this will be head and this will be the tail node, right? Now when I insert one more node here, now what happens? Tail will be here and head node will be there itself, right? So that is what I'll make it here. You can see here, head equals to nn as well as tail also, right? So I'll write head equals to tail is equals to nn. So that means if it is only create function, means only one node, head equals tail equals to nn. Now when you insert a node at the beginning, is the tail has to be updated? No, right? Let us suppose I'll make it like this. I'll try to write it again. So let us suppose my first node is this one, head and tail here. When you insert a node at the beginning, 20 here, now you can see what is the head. Head will be updated, that's why we have written. What about tail? The last node will be as it is. So that's why we didn't make any changes. We don't want to make any changes in the insert underscore begin. Why? Because every time when you make it, head is changing, not the tail, right? You are inserting at the beginning. That's why you can see line number 52, that head is the current node. Now the last one, anyway display, you are displaying one by one, not a problem. Now when you come here, insert node at the last. Now what happens if inserting the node at the last? I'll take the same example. I'll take this one with this example. I'll take this example where I don't want any temp, but head node is this one, whereas the last node, which is tail node, is this one, right? Where every time you are maintaining the tail node. So that's why what happens here is, instead of taking while loop, instead of writing this while loop, what I want to write here, we are readily available with tail node. So what is tail of next? Null. So that has to become with your nn. That directly you will get the answer. Why? Because see, previously what we have done is we have taken a temp and we are traversing till the last. But with the advantage of tail node, where tail is nothing but which is the last node, we are at the last node. So definitely directly connect to that, whatever the newly coming node, tail of next equals to nn. But one more thing you need to remember. Now once you connect this one, so tail of next here 4500, you got it. Now previously tail is here, now tail has to come here, right? So that is also very most important. That is tail also to be changed, where now the current tail node, see, when you insert a node at the beginning, head node is updated. When you insert the node at the end, tail is updated, right? So now tail is nothing but which is with the node 40, not with the 30. So that is what I am writing, tail of next. Anyway, what is tail as of now? Previously 2000 in this case. What is the next? Null. So now I made it as 4500 with this node. Now tail is equals to nn, means tail is updated. So like this we can make the updates here with respect. See, the code is very simple. You have to get that idea. And also you can see, is there any while loop or something loop? No in this. So that's why the complexity, I can say it is one complexity only. When you see insert at the end, there is no loop. So that's why the complexity is 1. So this is what you can maintain. This is what you can get the best complexity of inserting node at the end when you maintain the tail node. So I hope you are able to understand clearly. You can execute step by step. If you are stuck with somewhere, please go back and listen it again and you can get the clarity. Anyway, I am executing this also. If I give 1, 10 is my first node. Now you can see the display. Now I'll give 2, insert node at the beginning, 20. The display is like this. Now I'll insert at the last, option 5. So 30 if I give, what should be my output? 20, 10, 30. 30 is at the last. You can see the display 20, 10, 30. Like this you have. Again I want to insert one more at the end. 5, 60. Like this. So you can see at the end we are getting. And not only this, one more thing we have written is that if condition is properly working, if head is null, let us see that also. And I'll write here as initially what is the display, list is empty. Now if I go for 5, option 5 means insert at the end, already list is empty. If I go for a value 20, what should it has to do? It has to create a node with respect to this value. Let us see whether the display part you can see. Yes, perfectly fine. So with this you can go for option 2, 50. Yes, you can see the answer. Like this. At the end you want to give it yes. Option 5, which is 40, the value you can see. So this is what step by step you need to make it. The next option will make it, which is insert node at the particular position. That is what I'll write here. So insert node at a position means given a position you want to insert. Okay, I'll write here the logic first of all. I'll call the function. So for this we need two values to give input. One is value, other one is a position, or position and value, where you want to insert and what is the value. For that I'll just copy this one. I'll make the changes, you can see. For this I need to create a one more node, which is POS is a position, and I'll declare that variable POS position, and the function name is insert underscore position. So now I want to implement this one, insert underscore position. You can see. So two parameters. Position means I'll give it as P here. Now I want to insert this new node at a position here. Let us suppose this is a position 1, this is a position 2, this is a position 3 actually. In between 2 and 3 I want to insert this one. So I want to connect this one here, I want to connect this one, so that it will be established, right? So this is what you have to make it. How to make it this one? So this connection to be established and this also to be established. So I'm making. So this is where I need to first go to this position, right? So for that I'll take a temp variable where I have to go move into that. Now temp is here. Well, let us suppose temp has to move until you will get that position. Let us suppose second position means temp has to travel 2 times. If temp is k times, temp has to travel k times. That means temp has to travel p positions, p times. I'll write a loop. When temp is here, t is here, what you need to do? You can see. What are the changes you have to make? First thing, here instead of null, this has to go with this one, which is nn of next. Is that right? This is nn of next. What it should be? This address 3000. Where is that 3000 previously? You can see. This is temp, right? What is temp of next? 3000. So that must be updated. That must be updated. You can see temp of next. What is temp? Temp is here. What is temp of next? 3000, which you want to keep it in the nn of next. Now here 3000. Yes, this connection established. Now what about this temp of next? It is 3000, which has to be erased, and now it has to be in my nn value. Now temp of next should be, now previously 3000, if it is 3000 directly connected, now I need to make it so that which is our current address, which is nn. So two things has to be done. That's it. The answer will be over. Let us get the output. Of course nothing to do with the tail node as of now. And also one more thing you need to remember here. Again the same thing you need to do. If the list is empty, that means it should be a first node. Okay, and also you need to check it out. What if the position is the last? If the position is the last, there you cannot find the last node. That is also, I'll try to write it. Special cases also you can see here. Now again the same thing. First of all I need to create the node, and I need the temp also. I'll make it this one first. Okay, insert underscore a position, where I created a node here, same thing, and temp is started with head node. And also this one, if head is equals null, create function, this is also absolutely fine. Where if it is empty, again it has to create with respect to the value, okay, irrespective of what is the position. Okay, and of course you have to give the position within the constraints, right? So now you can see else part. What you want to do here is, I want to go to that position. For that I'll write a for loop. I want to count the positions. In order to count the positions, I'll take int I, where the variable I I'll take for I starts with 1. I'll check it out what is the correct option. I less than P. If it is, let us suppose P position is, I want to insert a third position here. So if P is equals to 3, you can take it as I equals 1, I less than 3 means I takes 1 and 2. Whenever it is 3 comes out. So when I equals to 1, what it has to do? When I equals to 1, we are writing simply temp equals temp of next. When I equals to 1, what is temp? Temp anyway here it is. Temp of next means going to this one. So one iteration is enough. If I P equals to 3, one iteration is enough, right? Not 2 iterations. If 2 iterations means it goes to the next, means this one. So we can write like, yeah, first I'll make it a general case like I starts from 1, I less than P minus 1, I plus plus, whether it will work out or not, let us see. Where I equals to 1, if it is 3, so it has to stop at the second here itself. So 1 it goes, and 3 minus 1, 2. So only once it has to go, it will go, which is yes. So I'll try to write like this, temp equals to temp of next. Temp equals temp of next, it will go, and once it is done, where temp stops here, once it is done, anyway if P equals 3 in our example, it first here, and next, what is the next time when it comes to the loop? I plus plus 2 is less than 2, no, comes out. Now temp stops here, temp of next 2000 means its temp stops here. Now what you are doing, you have to write here, I'm writing here, you can see. So which is nn of next, I have written in the down, nn of next equals to temp of next, and temp of next equals to nn. This is what you can make. And one thing we need to observe, what if it is position P value is 1, what happens? You can say I equals 1, 1 minus 1, 1 less than 0, no, directly comes out. What is nn of next equals temp of next? What is temp of next? It takes the next value, which is wrong. Okay, for this I'll take one more condition, else if P equals to first node, then directly apply. If it is a first node, can I say insert node at the beginning? Absolutely. So I'll execute that, insert underscore begin with the given value x. That has to be executed. Of course, else part, if it is not a first node. Now how to make it? Will it be applicable if it is a last node? That also you can check it out. So what if I want to store at the last here, right? So you need to stop here, temp, you can see nn of next. Nn of next equals to what? Which is temp of next. What is temp of next? Anyway, null, absolutely true. And temp of next equals to nn. That is also absolutely fine here. That is what you can make it here, and you can go for it. The point here to remember one more thing is, what if the tail node to be updated? Here anyway insert at the beginning, tail node will not be updated. Insert at a particular location, tail node will not be updated. I mean not updated, but it is end, you have tail node has to be updated. Okay, so that is also, if you want, you can write it. One more condition, how you can make it? So if the position you have to make it, which is null, that means when you go to the last node, where once you get it, here you can write it. If nn of next is still null, that means yes, you inserted at the last. So if nn of next is null, yes, that means you have to update your tail equals to nn. That means if you are inserting at the last, NN of next is null. That means you are inserting at the last. That's why NN is updated with tail is updated with NN. So like this you can make it, and we'll check it out. Any mistakes, anything are there, clearly we'll check it out. Yeah, so those who are executing, they can check it out the code clearly here. I'm erasing everything here. Yeah, this is what you need to write. I'm executing this one, we'll see clearly. Yeah, this is insert underscore begin, the function name. We have written only BH. Yeah, we'll try to make it anyway. Initially the display list is empty. Now if you want to go for create one, is there 20? Yeah, now one node I am inserting at the beginning, 10. One node I am inserting at the end. Anyway, we'll go for display first, 10, 20. Inserting at the end, option 5, 40. So the display part you can see 10, 20, 40. One more element I want to insert at the end, 50. So the display part is like this. Now I want to insert at the fourth position. That means 40 and 50. I want to insert something like, might be any number, 60 or 40, whatever. So our option is option 6. Enter a value and position. First I'll give the value. What value I want to insert? 60. And the position is fourth position. Let us see whether it is inserted successfully. Yes, perfectly fine, you can see. Now you want to insert at the third position, let us suppose. Option 6, and the value is something like 35 at third position. Let us see the display part. Yes. And of course we have written what if the position is 1, how you can make it. So let us see the position is 1. So I want to insert something like 25 at first position. Will it be inserted? Yes, we'll see the output. Yes, without any error you can see. So when you want to insert at the last, already there are 3, 4, 7 elements. I want to insert 8th position. So the value 70 at 8th position. Let us see, is this perfect? Yes, you can see. So this is what perfectly you can make it. You want to insert at a particular position. Even you can make it in between something. I'll write 45 at might be at third, might be at second position. Yes, you can see 45 at second position. So like this easily you can write the code. Of course you can see the complexity here. Of course I have written the for loop, but according to the position it will go. In the worst case means the position is the last one. Yes, you can go for n complexity here. So that is what, once you go to the position, I think you are not changing much, right? Let us suppose position is something like fourth position. They have 1000 elements, means remaining 996 elements you are not updating, only one element. Remaining 995 you are not updating. That is what the advantage here with respect to the linked list. So we have seen clearly how to insert a node at the end, how to insert a node at a particular position is given. So now we are done with the inserting node at the end, insert node at a given position. So we'll see deleting node at a beginning and deleting node at end and a particular position in the next video lecture. Thank you.